decoder circuit. The 5 cross 32 bit decoder, 2 cross 4 bit decoder, or 3 cross 8 bit decoder. Now, in today's lecture, we will start a new topic, that is multiplexer circuit. So, multiplexer is also a combinational circuit like decoder. So, we know that what is combinational circuit. So, a combinational circuit is basically a digital logic circuit whose output depends only on the present input. So, we know that there are two circuits in digital electronics. One is combinational sequence and second is sequential circuit. So, in combinational circuit, the output depends only on the present input. It does not have any memory. But in a sequential circuit, the output depends on the present input as well as the past input or the past output. So, it has a memory. So, we will discuss about sequential circuit in later videos. So, as for now, multiplexer circuit is basically a combinational circuit. So, its output only depends on the present input or present state of the input. So, it's a combinational logic circuit. So, in digital electronics, multiplexer is a combinational logic circuit that selects between several analog or digital input signals and forwards it to a single output line based on the select line. So, as for the definitions, we can see that multiplexer is a combinational circuit that selects between several analog or digital or analog input signals. So, you know that it has different analog or digital input signals, and from that input signals it selects one input signals and forwards it to the output signals based on the select line. So, this is basically the function of multiplexer circuit. So, we can see the circuit diagram of multiplexer circuit. So, this is 2 at the select line. So, x and y at the two select line, and this I0, I1, I2 and I3 at the 4 information or input lines. This is from the information lines or input lines. So, these are x and y at the 2 select lines, and these 4 at the information or input lines. So, this is the circuit. We first take the true value of the x and true value of the y, then complemented value of x and complemented value of y. We take it as a, for building the circuit diagram, we take it as a 0, 0. So, then first combination, so as it is a 2 cross, as it is a 4 cross 1 mux. So, what does it mean that 4 cross 1 mux? 4 cross 1 mux means it has 4 information lines, I0, I1, I2, I3 and 1 output lines. So, in the multiplexer circuits, the output line is always equal to 1. So, it only gives only single output. For a decoder, we see that for n input signals, we get 2 to the power n output signals. But for multiplexer circuits, for n or any kind of numbered input signals, we get only 1 output signal. So, this is the 4 cross 1 box because it is 4 input lines and 1 output lines. So, these are the 2 select lines, x and y. So, this is 0, 0. So, as it is a 4 combinations, 4 cross 1, then it has 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. So, for this is 0, 0, and this is again an input lines I0, and similarly 0, 1, I1, I2, and I3. 4 input lines are ended together, and then all the and outputs are get into a OR gate, and then we get the final output. So, this is basically the circuit diagram of a multiplexer circuit. Similarly, if you take 8 cross 1 box, then it has 8 information lines I0, I1, I2, I3, I4, I5, I6, I7. Similarly, 8 AND gates and 1 OR gates. So, and similarly, 8 cross 1 box has 3 x, y, and z, 3 select lines. So, based on the select lines, so what does a multiplexer do? Based on these 2 select lines, it selects from these information lines and sends one information lines as an output. It basically, based on these two select lines, it selects from these information lines and sends one input lines to a single output lines. So, first is 0, 0 combinations. So, for 0, 0 combinations, if x equal to 0 and y equal to 0, then we see that this is 1 and this is 1. So, for first combination, this is 1 and this is 1 and this is I0. So, 1 into I0, AND gate means I0, and 0, 0 means this is 1 and this is 0. So, 1, 0 is there. So, the ultimate result is 0. Similarly, this result is also equal to 0 and this result is also equal to 0. So, for the first combination of x and y, we get output as I0, right? For the first combination of 0, 0, we get output as I0. Similarly, for the second combinations like x equal to 0 and y equal to 1, the I1 pin is active. Only I1 output we get, and all other rest of the output is 0. So we only get output as final output as I1. Similarly, from 1 0 we get output as I2, and 1 1 we get output as I3. So we can see here that based on these two select lines 0 0, 0 1, 1 0 and 1 1, multiplexer selects only one input lines and sends it to output lines. For 0 0 we get I0 as output, for 0 1 we get I1 as output, for 1 0 we get I2 as output, and for 1 1 we get I3 as output. So this is the truth table of a 4x1 mux. So now we will see. So now you can see the block diagram of a multiplexer circuit. So this is a 4x1 mux. So this is a 4x1 mux, as it has 4 informational input lines. These are the informational input lines. Information or input lines, and this is select lines. These are the select lines, and this is the output lines. So this is I0, I1, I2, I3, and this is X, and this is the MSB. MSB is the most significant bit of a digit, and this is the Y, and this is the output Z. So you can see this is the simple block diagram of a multiple circuit. These 4 are the informational input lines I0, I1, I2, and I3, and these 2 are the select lines X and Y. This is the MSB, and this is the one output lines. So based on these select lines, it selects only one input line, so sends it to the output line. This simple block diagram of a 4x1 mux. So you can see a formula is there. See, if there are n select lines, then there are 2 to the power n number of informational input lines. So this is a formula. We have to remember the formula. So 2 to the power number of select lines is equal to number of input lines. If there are n number of select lines, then in that multiplexer there are 2 to the power n number of information lines. If there are n number of select lines, there are 2 to the power n number of information lines. See that if there are 2 select lines, so it means 2 to the power 2 means 4 information lines. If there are 3 select lines, or for 8x1 mux, there are 3 select lines, and 2 to the power 3 means 8 information input lines. And there is always one output lines in a multiplexer circuit. So now we will see the conversion of different gates like basic gates and NAND gate or NOR gate or universal gates using the mux. So now we will see the conversion of different types of gates using multiplexer circuits. So first we will see the basic gates, OR gate, AND gate and NOR gate. So while converting the different types of gates using mux, we have to remember the truth table of different gates. Like this is the truth table of OR gate X, Y, Z. 0 0 means 0, 0 1 1, 1 0 1 and 1 1. This is the truth table of OR gate. We have to implement this truth table in the mux multiplexer circuit. So this is the 4x1 mux, I0, I1, I2, I3. 4 input lines, X and Y select lines. This is the MSB, and this is the output lines. So if we give 0, 1, 1 and 1 as input lines, then we get same as this truth table. So see, if we give 0 0 as input, then we will get I0 as output, and we give 0 as I0. So we get, if we get 0 0 in XY, then we get 0 as output. This is the property of OR gate. And again, if we give 0 1, then I1 will be the output. So I1 is 1, so we will get 1 as output. This is the truth table of OR gate. If we give 1 0 as here, then we will get I2 as output. I2 is equal to 1, so we will get 1 as output. Then 1 1 is 1. If we give 1 1 as select as 1 1 is X and Y here, then we will get I3 as output, and I3 equal to 1, we will get 1 as an output. So this holds the properties of OR gate. This is the conversion of OR gate using the multiplexer. Similarly, for AND gate, this is for AND, we know the truth table. 0 0 is 0, 1 0 1 is 0, 1 0 is 0, 1 1 is 1. We put the 0 0 and 1 as input lines in this 4 cross 1 box. So if we give 0 0, we get output as 0. If we give 0 1, we get output as 1. If we give 1 0, we get output as 0. And if we give 1 1, we get output as 1. Similarly, for NOT gate, we only have two input signals. We know that for NOT gate, if we give 0 as input, we get 1 as output. If we give 1 as input, we get 0 as output. So here, as two input is there, x and y, so you have to sort that two input. So here we sort the two input x and y. Here we sort the two input x and y. So as if we give 0 as here, then same input 0 will be given to this x and similarly to this y. So this holds the 0 0 combination of marks. 0 0 means I0 is active and I0 equal to 1, we get output as 1. So if we give 0, we get output as 1. This holds the properties of NOT gate. Similarly, if we give 1 as here, then similar 1 output, 1 input will give as x and y. We get 1 and we get 1. So this is the order combinations of x and y of this marks. So order means the I3 pin is active. This is the I3, this is the I0. The I3 pin is active. Order means I3 pin is active. So we know that I3 equal to 0. So we get 0. So if we give 1, we get the output as 0. So this holds the properties of NOT gate. So as in this way, we can convert the NOT gate using the marks. We can also convert the NOT gate using the multiplexer circuit by sorting only one element. Like if we sort the x, then only y will be there. Then x will always be 0. Then there are two combinations possible: 0 and 0, 0 and 1. So if you give as 0 here, then we output as 1. I0 is active. If you give 1 here, then 0 means I1 is active. So in that way, we have to put the 0 here. To put the 0 1, 0 1 means we get. If we give 0 1, the I1 is active, then we get output as 0. If we give 1, output as 0. So this is the whole properties of NOT gate. Now we will see the conversions of exclusive gates and the universal gates using the multiplexer circuit. So now we will see the conversions of exclusive gates and the universal gates using the marks. So first is AND gate. So you know that for an AND gate, it gives the reverse output of AND gate. So if 0 0 1 or 1 0, we get 1 as output, and if 1 1 is given as input, then we get 0 as output for an AND gate. So similarly we put the 1 1 and 1 0 as an input, and based on the 0 0 0 1 1 0 and 1 1 combinations, this I0 I1 I3 pins are selects as an output, and this holds the properties of AND gate. Similarly, for a NOT gate, we know that truth table of NOT gate gives the reverse output of an OR gate. So it gives only high. It is only high when it takes the input as 0 and 0. Both are low input, it gets high, and but rest all the inputs combinations it is low. So it similarly puts 1 0 0 and 0 as input combinations in this multiplexer circuit. And based on this x and y 0 0 0 1 1 0 and 1 combinations, we get the output as we get in the NOT gate. Similarly, for an XOR, we know that XOR expression is y equal to output is equal to a bar b plus ab bar. So for XOR, we know that when same output is there 0 0 1 1, we get same input is there 0 0 and 1 1, we get output as 0. And when different input is there 0 1 or 1 0 combinations, then we get output as 1. So we similarly puts that similarly 0 1 1 and 1 0 inputs as I0 I1 I2 active in this marks, and based on this input based on the select line combinations 0 0 to 1 1, we get same output as we get in the XOR gate. Similarly, for an XOR gate, we know that XOR equation y is equal to AB plus A bar B bar. So if we give the different inputs 0 1 and 1 0, then it gives low output, and if we give same input like 0 0 1 1, we get high output. So similarly, we put this 1 0 0 and 1 for these input combinations. So based on this 0 0 0 1 1 0 1 1 select line combinations, we get same output as we get in the XOR combinations. These are the combinations of different types of basic, universal and exclusive gates using the multiplexer circuits. So in the next lecture, we will discuss about the 8 cross 1 marks and different types of multiplexer conversions. Thank you.